When an Unreal C++ build fails, beginners often blame the line they just edited. But pressing compile does not send one file straight to a compiler. Unreal first resolves the target, modules, plugins, and dependencies. It may generate reflection code. Only then does the native toolchain compile and link a module that the editor can load. In this lesson, we will trace that real pipeline, use a minimal project built on Unreal Engine 5.5, and separate a C++ error from a project configuration error. Our minimal project has two kinds of build rules. Compile lesson editor target says we are building an editor target for Win64 development and names the compile lesson module. Compile lesson.build.cs declares that module's dependencies, core UObject, and engine. These files are C# because Unreal Build tool evaluates them before native compilation. If you forget a module such as enhanced input or UMG, the problem begins here. Adding more include statements to a C++ file will not repair a missing module dependency. Unreal Build tool, usually shortened UBT, turns those rules and the .UPROPERTY descriptor into an action graph. It selects the target, platform, and configuration. It resolves enabled plugins, evaluates every required module, chooses the compiler and Windows SDK, and decides what is out of date. This is why an Unreal build can fail before any gameplay file is compiled. The first useful diagnostic question is not, what is the last red line? It is, which stage was the build actually in? Compile probe is an ordinary actor class with an Unreal reflection contract. The generated header include must appear after the other includes. UCLASS marks the type for reflection. Generated body inserts declarations created by Unreal header tool, and UPROPERTY exposes metadata that the engine can inspect. During our clean build, UHT parsed the headers, wrote 4 generated files, and produced compile probe.gen.cpp. That generated source is compiled beside our handwritten source. This is why a malformed reflection macro or a missing generated header is not a normal C++ compiler problem. After header generation succeeds, the native toolchain takes over. Our real log shows Visual Studio 2022, the Windows 10 SDK, and Unreal Build Accelerator executing 10 actions. It compiled the module source, compile probe.cpp, the generated initialization source, and compile probe.gen.cpp. Then the linker produced Unreal Editor-compile lesson.lib and .dll. The important idea is that your class is only one input to a complete loadable Unreal module. This is not a simulated terminal. The lesson project was generated in this repository and built against the installed Unreal Engine 5.5. The first build created the makefile, ran internal Unreal header tool, generated reflection code in 1.535 seconds, executed 10 native actions, and finished successfully in 38.09 seconds. The output DLL now exists under binaries, Win64. That artifact, together with the build log, is stronger evidence than an AI explanation that merely sounds correct. Now compare a real failure from the main project. UBT stopped in 0.85 seconds because the .UPROPERTY file requires the DLSS plugin, but that plugin is not installed on this machine. The stack trace ends in setup plugins and pre-build setup. There is no compile probe action, no C++ diagnostic, and no linker failure. The correct response is to fix the plugin installation or the project descriptor, not to rewrite gameplay code. Stage awareness prevents confident but irrelevant AI patches. Live coding is a fast patching loop inside the running editor. It is a good fit when an already compiled class keeps the same reflected shape and you change a function body, a calculation, or a log message. Treat structural changes as full build candidates, adding a new reflected class, changing UPROPERTY or UFunction declarations, changing module dependencies or plugins, or rebuilding constructor and default subobject structure. Some changes may appear to patch successfully, but existing objects and class defaults can preserve old state. When behavior becomes mysterious, close the editor, build the editor target from a clean process, reopen it, and verify again. Use this order whenever Unreal C++ fails. First, confirm the target and configuration. Second, check project plugins and module dependencies. Third, look for an Unreal header tool or reflection error. Fourth, inspect the first native compiler error, not the 100 follow-up messages. Fifth, separate compile failures from linker failures and editor load failures. In the next lesson, we will use this pipeline to create the first Unreal C++ actor, expose a property, place it in a level, and verify its begin play log.